Okay, so today's topic is about how to use PySpark and pipeline in general. So I think more or less you have an idea what I'm doing. My name is Parvaneh. I'm a data scientist. Now I'm working as a project team leader in NTT Data. So I have mostly worked in the consulting companies and work on the problems of applying data science and machine learning on business solutions. So about the RladiesMilan, a brief introduction. RladiesMilan, it is having the focus on providing and introducing diversity in the world of data science and machine learning, and of course promoting R as well. Maybe not, this is not exactly the right community to talk about R, but okay, I'm just joking. So we have also a national chapter, which is called RladiesItaly. So you can follow us in our meetup group. We have the same scope. So RladiesItaly is having more virtual events, but the objectives are still the same. So returning back to our topic today, what we are covering today. Well, in 30 minutes, I try to cover what is a Spark, how to use it, and the introduction about pipeline. Then we are going to see everything in practice in a use case. So for today's demo, I'm going to use Databricks, which is a big data analysis platform. But till this morning, I was going to use Colab, but then I thought that Databricks is going to be more focused on big data analysis, and it's going to be more useful at the end. So let's jump into the presentation. What is a Spark? A Spark is an open source framework for large scale distributed data analysis. It is released in 2014, and the current version is 3.2.1. So compared to the Hadoop, it is 100 times faster for large scale analysis. The core of Spark is based on the Scala, but it has also providing various APIs for various languages, such as R, Python, Java, and SQL. And as you can see, we have a Spark core here, but on top of that, we have various components, such as GraphX for graph computation. Then we have a Spark SQL for SQL analysis. Then we have streaming and MLlib, which is used for the machine learning. A Spark can be connected to various cluster management, such as Hadoop, Kubernetes, which is really trendy these days, Apache Mesos, and even a Spark as itself, so a standalone version. So couple of keywords which can be interesting to know. The first one is RDD, which is a fundamental data structure of a Spark. It is immutable, it can be cached, it can be persisted, and it allows to do in-memory computation on large clusters. So Spark doesn't have just RDDs. We have also data frames and dataset, which are more optimized version of RDD. So in our example, we are going to use data frame. Then we have a Spark session, which is a bit confusing with a Spark context if you know a Spark. A Spark session is a more advanced version of a Spark context. Anyway, both a Spark context and a Spark session are the entry point for using a Spark. The difference is that a Spark session is more new. It is introduced in a Spark 2.0, which encapsulates various contexts, such as SQL context, Hive context, and streaming context. And it is used for creating RDDs, execution of SQL, and so on. Then we have transformer or transformations, which are the operations that are performed on data frames, such as filter or join. So consider that transformations are lazy operations, which means that it is not going to be executed until an action is triggering them. So actions are computation, which are performing on data frame, such as count, first, show, and so on. We are going to see it in an example. So here a quick architecture of Spark, Spark architecture on cluster. So we have the driver program, which is the main functionalities of Spark. Then we have a couple of workers or executors. So as I said, driver program is the main function of our application, and it is creating the Spark context. So Spark context is going to connect the cluster manager, and the cluster manager is allocating resources to the cluster. So after a Spark context acquired the executors and the resources, it is going to use them to run the task or jobs. So tasks and jobs are going to be run on the worker nodes. So the number of worker nodes, it depends on your cluster. And the worker node is able to run the application code in general. Then we can have multiple executor on the worker. It depends on the core number of your machine. And they are responsible for running operations practically. And then we have the tasks, which are the minimum or smallest unit of the work. Because first you have the job which is need to be done in a cluster. The job is divided into the stages. And then inside the stages, we are dividing the stage into the task. So the tasks are dependent to each other. So how to use a Spark? If you want just to experiment a Spark, maybe even learn it, you can install it on your PC. Not fast, but you can configure it anyway. Or you can use public clouds, Azure, AWS, and so on. Or you can use the platforms such as Colab or Databricks. So for today's demo, we are going to use Databricks. And the last part for the theory, we have the pipelines. So pipeline, as the machine learning pipelines, are kind of various processes which are followed together to form a workflow. So they are used to like order your code, and even when you want to share it with others or carry your work to the production, it would be easy and fast. So the pipeline is including various stages. Each stage can be data transformer or an estimator. So what are transformers? They are used for transforming your data frame, and the result is that you're adding a one column or multiple columns to your data frame. And it is always followed by the transform function. Then we have the estimator, which are responsible for fitting some algorithm on your data. It is always followed by the fit function. So I think that's enough for the theory part. Let's move to the practical part that we are going to see this part in action. I was trying to minimize this, but maybe, okay. Anyway, so if you open the Databricks, you can, this is the Databricks community version. I forget to mention that. So you can register in it free. You don't have to pay anything. Of course, the resources are limited, but that's going to be fine for doing exercises and practicing. So the first thing that you're seeing is going to be the main workspace. Here I can see my recent works, but let's explore the left sidebar menu. So we can create notebooks, create tables, create clusters. Well, for running any Spark job, you need to create a cluster. So if you want to create a cluster, you're going here, you specify the name of the cluster, and then you have various versions of your Spark and Scala, and there you go. If you don't have any preference, you can leave the configuration as it is. So for example, here I can go to the compute part, and I can see what are my previous cluster that I have created, or the one which is running right now. So the next thing is that you have the data. So you can create a table. So it means that you can create a SQL table, or you can upload it directly on your, sorry. I can hear some noises, Michele. Could you please mute your microphone? Okay, thank you. So you can upload your file directly here, or you can connect to to S3 or other formats. So for example, here I have uploaded already my files and I can find them on the file store, on the tables, and you can see a couple of CSV files, but I'm using these two data sets, which are used for the training and the testing. So if you want to create a notebook, it's easy as specifying the name, specify the language, and then the important part is that you have to allocate the cluster that you have created before in this part. Else, your code is not going to be executed. So let's move to the execution part. For the first part, I need to load my data. So as you see, I don't need to even import PySpark because it is already provided by the Databricks and it is running by itself. So the data frame that the dataset that I'm going to use is a California housing dataset. It includes various information about the house in various blocks of California that we are going to see shortly. So I can use a spark.read.load in order to read my CSV file. I need just to specify the format, if the data is having header, and ask the Spark to infer the schema automatically. So as you can see here, as I execute this part, I can see what are the jobs that have executed before. So one thing which can be interesting to see is the Spark user interface, that by calling this bar, I can see, maybe if this is not running, I can show you some examples that I have opened before. Here you can see, for example, what are the total number of the jobs that you have done. For example, here it is around 200 jobs that I have executed before. Okay, this is like a timeline that you can see how the jobs are executed. And in the bottom, you can see what are the previous jobs that have executed before. So the time it is submitted and the duration. So sometimes this part may not be open. As you can see here, it is not loading. So that's going to be fine because I have opened it before, so you can see already. So for the processing part, let's have a quick look at the data. So as you can see, I can just call .show in order to have a quick look at the data. So we have the longitude, latitude, housing median age, which indicate the median age of the house in a specific block, the total number of rooms, total number of bedrooms, population, number of households, median income, and the median house value. This is the target that I'm going to use for the machine learning modeling. If you are interested to see the schema, you can use print schema to see the name of the columns, the type of them, and if they can include null values. So if you need to see the name of the columns, it is just easy by calling housing.columns. So you can have a list of the columns that we have seen already. If you want to select columns, just use the select and then pass the name of the columns that you are interested to see. You have to always call an action. So for example, here .show is going to execute what it is done before. So just to show you, if we call this part, okay, I think my Spark cluster is not running right now. I don't know because Databricks had some problem this morning, and anyway, I expected this part, but anyway, if you run this part, you won't see any output because they are like the lazy transformations. After you call .show, which is an action, you're going to have the output and the return values of these specific comments. So be careful of that when you're running your Spark script. Another interesting and important library in Spark is, in PySpark, is SQL functions, which are including multiple functionalities. For example, if you would like to select columns, if you would like to find mean value, max value, and so on, you can use them directly. And they are really having similar functionalities as SQL. So for example, here, I want to see if my data frame is including any null values. So I have defined a function, and I'm looking through my columns, and then I'm filtering the rows. So I'm specifying by f.call, which is the function, and specifying the columns that I'm interested, if there is any null values in the data frame. And then at the end, I'm running count over it. And as you can see here, I don't have any null values. So better for us, we can go for the data modeling easier. So this is the last part that we are going to see in the pre-processing, which is like you can also easily do the group bys. For example, here I want to understand what are the mean value and or max values based on the housing median age. So it's enough that I run a group by and then apply an aggregation function and then specify the mean value of the median house value, which I'm interested in. And then you can rename the output column by running an alias over the output. And then here I just order by the median house, the house median age, and then calling the show to see the output. If you need to have a better visualization, you can use display over the above script that we have seen. So for example, here we have the output as a table, but Databricks allows you to also change the output as a bar or other types of the graph that you're interested. So let's go toward the modeling, which is allowing us to move to the pipeline as well. For a Spark, if you want to use the modeling, you cannot feed directly your features into the model because you need to convert them to a vector. So fortunately, you can do this by a package which is called Vector Assembler. And here I just imported from ML feature package. And then what I need to do is to select the features that I want to fit to my model. So in this case, I'm interested into these features, which are practically all of my features, apart from the median house value, which is like the target column, and the first two coordination of the block. So here I specify, okay, these are my features, and then the vector assembler is expecting two input. The first one is the input column, which is the feature, and the output column, which is the outcome of the name of the column that we would like to keep the vector. And then we just need to call the transform over my training data. So transform is a transformer, as we have seen in the slides. And this is, let's print the output. So as you can see, I have an added column, which is called feature. So let's see it also in the table. As you can see, the feature column is including a vector, which is an integration of these values. So we are good for going for the modeling. For the modeling, we had our training data. So let's read also the testing data. It is same as before. I'm just loading the file as the CSV. So here I'm just checking if the data is good. So far, so good. And then one important step is that I also need to transform my data as I did for my training data. So I'm applying the feature vector assembler over my testing data frame. So as you can see, I have also an extra added column to my testing data set. So it is also ready for applying the modeling. So here I just read the number of rows in both data set. So for the training data set, we have around 17,000 rows, and for the testing, we have around 3,000 rows, which is not a big data set, but it's okay for the objective of this talk. So I'm using a linear regression for the first part in order to do the modeling. So it needs two parameters. The first one is the feature column. So it is the feature column that we have created, and then the label column, which is the target column that we need to predict. So we are fitting the model over my training data, and then for the prediction, we can use the transform function over the testing and the training. I used also the prediction over my training data because I need to evaluate the performance of my modeling. So let's see the prediction over the testing data set. As you can see, this is the target, this is the prediction. Well, just by looking by the eyes, we can see, okay, it's not so bad. But how we can evaluate it better? We have the regression evaluator, which is a module which you can import directly from PySpark ML evaluation. So it is expecting two inputs. The first one is the prediction column. So as you can see that we have the prediction and also the label column, which is the target variable. So here I'm creating a regression evaluator, and then I'm passing my prediction output. So here, this is what for the training data set, and in the below, you can see it for the testing data set. By default, this evaluator is returning a metric of root mean square error. If you are interested to extract others, you can specify by a parameter dictionary, such as you can extract like R squared or mean absolute error. And then here at the end, I'm creating both of them. As you can see, well, the R squared for training and testing are slightly better than a random model, but okay, the perfect modeling is not the scope of the talk. So let's see how we can encapsulate everything in the pipeline. So in the pipeline, I'm going to start from the beginning. So I'm reading my data, this part for the training and this part for the testing. And then what are the main stages that we need to do both on the training and testing data set? The first one is vector assembler, so converting our feature to a vector. And the second one is the modeling. So as you can see, here I have created these two stages, and then I need to import pipeline. So pipeline needs to understand what are the stages that we need to apply on our data frame. Be careful to specify the stages in order because they're going to be run in order. So the first step is converting our feature, and then the second step is doing the modeling. Then the next step is going to be easy. I have created my pipeline, I'm fitting it on the training data set, and then I'm doing the transformation over my testing data to have the predictions. And that, as you can see, we have the predictions which are exactly the same as we have also above. So let's change a bit. How about the case that, for example, you have null values in your data set? Well, here I am using a column such as population, and I'm assigning randomly some null values to it. So here I'm calling the previous function that we have used to check if we have any null values. As you can see, we have around 2,400 values as null. So how we can do the imputation? Fortunately, Spark is also having a module for that. I'm importing it, and then I'm specifying 3 parameters. So here, this is the general approach. Then we are going to see how to add it to the pipeline. So the first part is that I need to specify which column I want to impute. And then we need to specify the name of the output column and then the strategy. So here I'm asking the imputer to impute the null values with median values of the population column. So the next step is similar as we have seen before. We have the fitting and the transformation over my training data set. So as you can see, the output, we don't have any null values on the population data frame. In order to add also this part in the pipeline, let's go to this part. I do another modification, which I change also my model here. So I'm going to use decision tree over the linear regression. So I'm specifying 3 stages. First, the imputer. Second, doing the feature assembler, and then decision tree regression. So decision tree is similar to linear regression. We just need to specify the feature and the output. So we are adding in order the same kind of a step that we did. So imputer, vector assembler, and then the modeling. The rest is same as we have seen above. So I'm going also to this part. If you need to save or load your model, your pipeline, sorry, what you should do. But before that, why you may need to do this? Maybe you would like to share your pipeline with other colleagues, or you want to reuse your pipeline in other projects. So this part is as simple as calling your pipeline.save and then specifying the name of the path that you would like to save your pipeline. And for loading, you just need to do the same, just you have to call pipeline.load and then specifying the path that you have saved your pipeline. And then as you can see here, my pipeline is loaded, and then I'm fitting it over my training data, and then I'm using it for the prediction. And the prediction, okay, it's similar as we have seen in the previous. The last part that I'm going to talk about is the case that you want to do the cross-validation when you have the pipelines and you want to tune your parameters of your model. So in this case, I want to use a decision tree regressor and I want to tune its parameter. So we need to import two new modules. The first one is cross-validator from ML tuning and parameter grid builder, this from the same package. So here, what is added to the previous code that we have seen is that first we need to create our grid builder of the params. So I need to tune, for example, the max step parameter and the number of max beams. So we are just adding add grids, and then we are calling the build over the param grid builder. So we have created this object. Then we need also to add the evaluator, which we have used before as well, which is regression evaluator. Then here, this is the cross validator, which is encapsulating everything. It needs the estimator, which is the pipeline that we have used before, which include 3 stages: imputer, vector assembler, and then the modeling. Then we have the estimator parameter map, which is going to be the object of the param grid builder. Then we need the evaluator, which is the regression evaluator that we have seen above, and then the number of the folds, obviously, that you want to use for your cross-validation. The rest of the step is same as before. So we need to feed the cross-validator over our training data. So I'm including the one which includes null value, and then I'm applying it over my testing data frame. And then at the end, it's about just the evaluation of the predictions. So that's it. I hope you learned something new. I tried to encapsulate maybe a mini course of Spark. I hope that you learned something new. Thank you. If there is any question, please share with me. The floor is yours.